Flammable liquids are among the most common hazmats transported and utilized that a responder may encounter in emergency response. Flammable liquids are classified by the U.S. Department of Transportation as a hazard class 3. Flammable liquids are defined by OSHA as a chemical with a flash point less than 100 degrees Fahrenheit, or for the U.S. Department of Transportation, chemicals with a flash point less than 141 degrees Fahrenheit. The definition of flash point is the lowest temperature at which a flammable liquid will give off sufficient vapors to ignite in the presence of an ignition source, such as ethanol has a flash point of 55 degrees Fahrenheit. But you've got to keep in mind that temperature is not everything. In addition to temperature, to have a fire, you must also have the right concentration of vapor mixed with the oxygen in the air. We call this concentration of vapor the explosive or flammable range. This range is defined by a chemical's lower explosive or flammable limit and its upper explosive or flammable limit. The wider the flammable range, the greater the risk for fire under normal conditions. Each flammable liquid and gas has a unique concentration or flammable range. The lower explosive limit is defined as the minimum amount of vapor concentration mixed in air to ignite. Below this concentration, a fuel-air mixture is too lean to burn. Our example, ethanol's LEL is 3.3%. The upper explosive limit is defined as the maximum amount of vapor concentration mixed in air to ignite in the presence of an ignition source. Above this concentration, a fuel-air mixture is too rich to burn. Our example, ethanol has a UEL of 19%. When it comes to flammable liquids, it's not really the liquid that burns, but rather it's the vapors. To be able to predict how easily a liquid can give off vapors, we need to look at some physical properties of the chemical, specifically vapor pressure and boiling point. Vapor pressure is defined as the pressure exerted by a chemical's vapor on the walls of a container at a given temperature. This temperature is usually referenced at 68 to 70 degrees Fahrenheit. Vapor pressure is typically listed for liquids as millimeters of mercury. Water, as an example, has a vapor pressure of 20 millimeters of mercury at 68 degrees. But the most important part to remember is that temperature influences pressure. The greater the temperature, the greater the pressure. For chemicals that are true gases, the vapor pressure for gases is usually listed as ATM, or atmospheres. It takes 760 millimeters of mercury to equal 1 ATM. This makes sense since gases are stored and shipped in cylinders at higher pressures. Our example, ethanol, has a vapor pressure of 44 millimeters of mercury at 68 degrees. In addition to vapor pressure, boiling point is the other main physical property that can help you predict how easily a liquid chemical can give off vapors to the atmosphere. Boiling point is defined as the temperature at which a chemical's vapor pressure exceeds the ambient pressure surrounding it. Ethanol's boiling point is 173 degrees Fahrenheit. When a chemical has a low boiling point, it rapidly gets into the air. 173 degrees may not sound like a low temperature, but compared to water's boiling point of 212 degrees, it's considerably lower. To help visualize vapor pressure and understand boiling point, we have preheated a pan close to the ethanol's boiling point of 173 degrees. In the thermal imager, you can actually see the push to go from a liquid into a vapor. In summary, when conducting a hazard assessment on a flammable liquid, always consult the physical properties we have covered and watch out for chemicals that meet the criteria. A chemical with a low flash point, a chemical with a low lower explosive limit, a chemical with a high upper explosive limit, a chemical with a high vapor pressure, and a chemical with a low boiling point. But alcohols like ethanol have one additional hazard to consider when they do burn. The flames burn almost invisibly, and have hardly any smoke to give you a warning.